So the quote for chapter 18 is from Otto Witt. In the strictly scientific sense of the word, insolubility does not exist. And even those substances characterized by the most obstinate resistance to the solvent action of water may be properly designated as extraordinarily difficult of solution, not as insoluble. So we'll find out in this chapter that you were lied to a lot in Chem 1A, basically. It was for your own good. It was. So you may be aware that antifreeze, ethylene glycol, is very dangerous for animals because it's toxic and it tastes sweet. It's also toxic for humans, but most humans know better than to drink fluorescent green things that they find in pans on the floor in the garage. So ethylene glycol is an alcohol, and so the first symptoms of ethylene glycol poisoning resemble drunkenness. But then it's metabolized to glycolic acid, which enters the bloodstream and changes the acidity of your blood, changes the pH. And that's what makes it so dangerous. Blood pH is very important. There are a lot of proteins that only function between 7.36 and 7.42 in humans. The range in animals is slightly different, but it's also narrow. So you change the pH a little bit, and all kinds of bad things happen. How does your blood keep the pH so constant? It has a buffer system. A buffer is a chemical system that resists pH by neutralizing added acid or added base. You put acid in there, it neutralizes it. You put base in there, it neutralizes it. It's kind of like magic, right? So one of the important buffers in blood is carbonic acid and bicarbonate ion. So carbonic acid, if it encounters hydroxide from a base, will neutralize that and become water and hydrogen carbonate ion, or bicarbonate ion. Bicarbonate ion is the other part of this buffer, and if it encounters acid, it becomes carbonic acid, neutralizing the acid. But if we have large enough quantities of glycolic acid, it can overwhelm the buffer capacity and cause the pH to drop to dangerous levels. So low blood pH is called acidosis, and you may have heard of ketoacidosis, which is something that diabetics have to worry about. This increased acidity or lowered pH affects the equilibrium between hemoglobin and oxygen. Hemoglobin is the protein that carries oxygen around to the tissues of your body. So hemoglobin plus oxygen becomes this, compound. It's not a compound, it's a complex maybe. And it releases a hydrogen ion. So if there's extra hydrogen ions in the blood, that's going to shift the equilibrium here to the left, and the hemoglobin is not going to be able to pick up the oxygen as it comes through your lungs. So basically, you're suffocating from the inside. You're getting air, but your body can't use the oxygen air. So you see hyperventilation followed by coma and death. An interesting treatment for ethylene glycol poisoning is the administration of ethanol. Ethanol is the alcohol in beer and wine and vodka and all those things that people drink. And the reason this works is that your body prefers to metabolize ethanol. And so if you've got a bunch of ethanol in there and a little bit of ethylene glycol, the body's like, I'm going to do this first. And it'll, keep it busy with the ethanol until the ethylene glycol can pass through. So I guess, the lesson there is if your dog drinks antifreeze, give him a beer. Any questions? This section is more about showing practical application of buffer systems. I'm not, going to test you on the minutia of that section.